Continuity of a function at a point. How do we define continuity of a function? Before we discuss the mathematical definition, let us first understand what it actually means. Suppose your exams are approaching in a week and you decided to study for 4 days. Then take a break on the 5th day and then again study for 2 days. This means that you are discontinuous in your studies because you took a break and did not study on the 5th day. If you study for 7 days, then we can say that you are continuous in your studies. So this is the basic meaning of continuity because it literally means without any breaks or gaps. If there is any break or gap, then we can call it discontinuous. The same idea applies to this function. If the graph of a function can be drawn without any break or gaps, then we can call this function as a continuous function. If there is any break or gaps in the graph of a function, then we call the function as discontinuous. Therefore, mathematically, a function f of x is said to be continuous at a point x equals to a if limit f of x when x approaches a is equal to f of a. Let us understand this definition with the help of a graph. Consider a function that has no breaks or gaps. Now, as we are looking along the x-axis and approaching a, we are basically hoping that the value of the function is approaching a value which is same as the value we get when we substitute a in the place of x in the function. This is what the definition is saying, and this can be true only if 3 conditions are satisfied. And what are those 3 conditions? First, f of a exists. Second, limit f of x when x approaches a exists and it's finite. Third, limit f of x when x approaches a is equal to f of a, which means that if a function f of x is said to be continuous at a point x equals to a, if the left hand limit of f of x at x is equal to a is equal to the right hand limit of f of x at x equals to a, which is further equal to the value of the function at a. If these 3 conditions are satisfied, we can say that the function is continuous at the point x equals to a. For example, consider this function. As we can see that at x equals to 2, f of x equals to 1 upon 2, so we can say that f of 2 exists and is equal to 1 upon 2. We can also see that the left hand limit of f of x at x equals to 2 equals to right hand limit of f of x at x equals to 2 equals to f of 2. Therefore, we can say that the given function is continuous at x equals to 2. In most of the cases, we consider the function as whole, but in many cases, we may only consider certain pieces of the function. And if a function is discontinuous, it can still be continuous on certain intervals. For example, if we consider this function, we can straight away say that this function is discontinuous by just looking at the break and gaps in the function. But what if we want to determine the intervals where this function is continuous? Let us see how we can do this. If we look at the function on this interval, we can say that the function is continuous because if we take any point on the x-axis, the limit of the function exists and is equal to the value of the function at the point. So we can say that this function is continuous in the open interval minus infinity to 3. Now consider the point x equals to 3. As you can see that there is a gap at x equals to 3, which also means that the left hand limit and the right hand limit of the function at this point would not agree to the same value. So the function is discontinuous at this point. Now this interval also looks good, so we can say that this function is continuous in the open interval 3 to infinity. Therefore, this function is continuous in this interval. So this is the basic concept of continuity of a function.